get you. It's a bit noisy in the background.
This call is now being recorded.
Well, that noise is not from here.
Okay, so if there's someone who has unmuted, please let's mute our mics. Oh, Sir Joshua, please help us to mute everyone that is not presenting. Thank you. You can go ahead, sir.
Okay. It is my delight to be among you mathematics enthusiasts. My name is Dr. Babalogbon Ayodeji. It is my delight to be here among you, and I am to present on the topic measurement of impact, knowing your footprint, and therefore using that information to decide for a greener future. And it is a privilege to make this presentation on the occasion of the World Environment Day for 2025. This is my outline or the structure of what you are expected to get in the course of this presentation. After explaining some of the keywords in that topic, we are going to see how mathematics applies and what are the implications for us, especially how our activity can be measured and use that information to ensure that the present climate challenge that we have is mitigated. So, two keywords. Please, are my slides changing?
We are on introduction, sir.
All right, thank you very much. All right. So, two keywords emerge from this topic: measurements and footprints. What is measurement? Measurement is a process that allows us to get an idea of how big or how small something is. And from that information, we can make comparison with other things, such as standards, and therefore we'll be able to judge whether what we have measured is within standard or below standard or above the standard. And footprints, what does it signify? You know, when we walk on the sand beach with our foot or with shoes on, we usually leave a mark on the beach. Even maybe a wet foot on a dry floor, we can see the mark of our foot. So this represents the mark we leave behind by our activity. But within the context of environmental science, this footprint signifies the negative effect or impact of our activity. The main principle behind this presentation is that if we have an idea of how large or how small something is, we can make a decision with respect to a standard. If what we have measured is not up to standard or is beyond standard, we can make the decision to make what you have measured come within acceptable standards. So in the course of these presentations, we will see how individuals, communities can apply mathematics to ensure that their daily activities does not make an impact on the environment. Though it may make impact, but does not make such significant impact that the future is greatly threatened. And one thing I appreciate when I came into this presentation is I realized that many of us are young and we still have a lot of decisions to make ahead of us. And it will be my joy if some of the little concepts we have gotten from this presentation is adapted into our daily life, such that we can ensure a greener future ahead of us. So now, back to our question, why are we measuring? We measure because we want to have an idea. Now, what are the footprints that we want to measure such that we can now have an idea of what our activity is impacting on the environment? There are three principal areas we want to look at. The first one is the carbon footprint. The second is the water footprint. And the third is the waste footprint. The previous presenter has laid a very good foundation as an environmentalist in to this presentation. And some of his explanations serves to provide the context for us to understand what this presentation is all about. When it talks about greenhouse gases, the principal culprit is carbon dioxide, which is CO2. And another potent greenhouse gas is methane, which is CH4, which has 100 more times power than carbon in and than carbon dioxide in constituting, the warming effect of greenhouse gases. So the constituent of the atmosphere is what controls our weather and of course the climate. So when the constituent of this atmosphere is changed by greenhouse gas emissions that are out of balance with other gases sustaining our atmosphere, then we have what is called climate change. Now, the other one is water footprint. Many of the activity we perform at home and many of the industrial activity that supports what we consume, what we use on a daily basis, they also use water. So how can we make choices such that our daily activity will not negatively impact our, water footprint? Then the third is waste footprint, which is waste generation and management. Even in the biological world, wastes are being generated and they are being recycled such that we don't even know what waste is because the output from one system is the input to another. But just as the previous presenter has said, our appearance on the Earth's surface has, disturbed the balance of things. So we'll see how the measurements of the impact that we have on the environment can provide information about the state of our environment and how we can adjust accordingly. So indicators like atmospheric and sea temperatures, precipitation, especially in the tropics, which is in form of rainfall, pollutants in various media of the environment, the air, water, and soil. We'll be able to use those information to create a feedback and adjust our processes in the daily life. So mathematics will help us to
Please, Sir William, could you mute yourself, sir? Thank you.
our cars and we're on the road, we are emitting carbon dioxide. Whenever we bring out our generator, it's very common in Nigeria, especially in some places where electricity is not regular. Generator also creates carbon dioxide into the atmosphere. So we can imagine the various, cars, generators, and other engines that burn carbon-based fuels, how much, they emit into the atmosphere. Electricity too, some power stations that supply the electricity we use also pollute by emitting carbon dioxide into the atmosphere. So As a result of this, we might want to take a look at our itinerary, the way we use cars. How often do we use cars? Do we, when we make short distances, are we, very used to our cars? Can we use alternatives that will not create fumes into the atmosphere and alter the constituents of the atmosphere? So making adjustments in these areas can help us to limit the amount of emissions we make into the atmosphere. Then in terms of food consumption too, in the production of meat, especially cattle belch methane into the atmosphere. And the methane they belch into the atmosphere also contributes significantly to climate change. So making a choice to eat plant-based foods compared to animal-based foods can help us to limit the amount of emissions we put into the atmosphere. And even when we choose to eat meat, we can choose to eat meat that does not so much emit carbon dioxide or methane into the atmosphere. For example, chicken, fish, pork are alternatives to cattle. Cattle emit the highest or produce more emissions than all these other meat alternatives. So we can choose to limit the amount of beef that we eat and try to look at those other alternatives and eat more vegetables. So this can help us in our reduction of carbon footprint. So we can see how mathematics apply. For every liter of fuel we burn, for every kilowatt hour of electricity we use, for every kilogram of meat or beef that we buy, we can use this to have a picture of how much carbon footprint we are making into the environment. So by multiplication of the factor and by summing them together, we have an idea of what we are emitting into the atmosphere. We can see an example of a calculation here. Driving 20 kilometers per day on a petrol car using 8 liters per 100 kilometers. We have estimated that 1.6 liters is used per day. And for every 1.6, for every 1 liter, we have about 2.3 kilograms of carbon dioxide emitted. So per day, we have 3.66 kilograms. Per year, we know what that amounts to. So we can choose to limit the extent in which we use our cars. If we are going just for a walk or for a short distance, we can choose to take a walk. We are reducing our carbon footprint. And if you compare this, although Africa, especially Nigeria, does not, produce as much greenhouse gas per capita compared to other developed nations. But in our own way, we can do our part because information shows that in the urban areas, this consumption per year per capita is rising. If you take a look at the next chart, I hope it is clear to you. This data is provided by NASA along with the Goddard Institute for Space Studies. It shows the plottings of the global land ocean temperature index. We can see fluctuations from 1880 to 2024. And we can see that gradually this curve is going up. So with mathematics, we can have a picture of what exactly is going on. And according to this data, 2024 is the warmest record.
Of these people,
The
we can't see any
warmest
graph.
year. Okay, but you can see application of mathematics and figure 1.
Yes, sir.
Okay.
Application of mathematics. Yes.
Okay, so it seems maybe it's blur. I'm so sorry. That is kind of faint. So perhaps maybe when the slide is shared, we can have a picture of that plotting. So we can see how the Industrial Revolution and other major advancements in human civilization has contributed to higher temperatures. These higher temperatures are as a result of The imbalance in the gases we have in the atmosphere, the CO2 and the carbon and the methane that trap infrared radiation that's supposed to escape to space. So with this increase in the concentration of these gases, we have higher temperatures, and these higher temperatures precipitate weather patterns that are unpredictable, that are different from what we know, and we term them climate change. So in our own little way, whatever we know produces CO2 in industrial gadgets in our homes, we can choose to limit such. So the next area we want to examine is water footprint. In Africa here, I was interacting with a colleague today, and when we were talking about water use, he said that we are relatively enjoying in Africa because anyone can just dig, and get water, although it is not everywhere in Africa. But in most developed countries, water is very scarce. They have developed, very complex water management systems such that whatever water is used in any household is being recycled. This water, whether it's from their toilet, from their kitchen, they are being transferred back into the water treatment plants, and from the water treatment plant, this water is treated to various degree of purification such that this can be channeled back to the taps for people to use. So you agree with me that in such a system, the way water is used definitely will have an impact on the environment, because the higher the amount of water used, the higher the amount of energy that will be required to make this water good again after it is being used. And so by managing our water use, and therefore in an indirect way managing the energy we use to get this water, we can reduce our impact on the environment. So whether we want to have our bath, whether we are taking our laundry, or in the kitchen, or in the toilet, we want to manage the amount of water that we use per day. Then our choice of food as well is something that we also need to monitor, because various types of food has various degree of water requirements. Rice, for example, uses a lot of water. In fact, cereals requires a lot of water. Cereals like maize requires a lot of water for them to grow. Meanwhile, there are some other forms of food that don't require so much amount of water to grow them. Crops like tuber crops, maybe cassava, yams, sweet potatoes, all those alternative for food does not require so much water. So, in a way to reduce our impact on the environment, we can, you know, reduce our dependence on certain kinds of food. Rice is a very common food in Africa, and to grow rice, the rice is grown in wetlands, anaerobic environments that emit also methane to the environment. So when we reduce the production of rice, it will also reduce the amount of water footprint used, and also emission to the atmosphere. So
Sorry to interrupt. Time reminder, we have 7 minutes remaining.
okay, thank you very much. Thank you very much. So let's go to the third, which is waste footprint. We talked earlier that in the natural world, there is no such thing as waste, because God has designed it in such a way that the output from a system is the input to another system. This CO2 we are talking about, which is a main culprit in climate change today, is not a problem in the past, because we have significant amount of vegetation that takes in this CO2, converts them to biomass in terms of wood, tissues, or structures, and produce oxygen in the process. And even photosynthesis takes this carbon dioxide and give up food in the process. So when we talk about waste, we talk about things like our food waste. Maybe we are used to
So sorry, Doc, we
eating,
can't see your
we
slide
just eat
again
apple.
at all. Almost 2 minutes.
Okay. Okay. Is it visible now?
It's visible on my end. I don't know, maybe other people have challenges, but I can
Okay.
see your own application of mathematics now.
I'm measuring food, making waste footprint.
Measuring, yeah, measuring waste footprint. Yes.
Exactly. Exactly. So regarding waste footprint, let me go straight to the point. We have what is known as landfills today. In landfills, we see all sorts of wastes there, both degradable, that is biodegradable, and non-biodegradable waste. And this is a problem because you cannot incinerate everything completely, and neither can everything undergo biological degradation. So the existence of landfills are served as one, eyesore, two, environmental damage, because this landfill serves as a refuge for pests, mosquitoes, rats, that threaten our lives. And the little material that are degradable in landfills, they also emit greenhouse gases into the atmosphere. And whenever we pass by where there are landfills, we can see the odors, emanating from such. So when we manage our wastes, we also manage our footprint on the environment. We want to, ensure that we don't waste food. When we eat out or when we eat at home, it's not a sign of poverty. When we clean our plates, when we eat everything on our plates, it's not a sign of poverty. We are trying to be good to the environment because such materials end up on landfills at the end of the day, and they constitute a nuisance to our environment. So we want to practice what is known as waste sorting. We know the kind of waste that can decay or degrade in the environment. We want to separate them from things like nylon or some other non-biodegradable waste. And our biodegradable waste, we want to convert them to things like compost. There are a lot of videos that can teach us how to convert these biological wastes, perhaps food scraps, maybe the peel of yams, the guts of fish, meats that we rinse to cut out dirty parts, and some those other waste that we cannot do without, eliminating. We want to collect them separately and treat them in such a way that we can use them for gardens in our homes to produce vegetables for us. So when we sort our waste and ensure that, you know, our waste does not end up on the landfills, we can conserve our environment. We can reduce our waste footprint and ensure a greener future. Agriculture is also a source of significant waste because about 30 to 40% of food harvested waste. An example is tomato. We are presently in the tomato season in Nigeria. Tomato is very cheap, so people may not be able to consume as much as is produced. And what is not consumed gets wasted because they are not managed. They are not processed and preserved. So when we add value to our primary production in agriculture by preserving what we have produced after harvest, we also reduce our waste footprint and we ensure a greener environment for the future. So by having an idea of how much waste we generate per day, per month, per year, and the proportion of it that is compostable, we can know, we can measure how well we are treating our environment. So on rounding up, what are the implications of these measurements of, how much water we are using, how much emissions we are taking into the atmosphere, how much waste we are dumping into the atmosphere without being properly processed. These numbers will give us an idea, will help us to visualize the impact of what we are doing. And when we realize this impact, we can have the desire to change. And when we have the desire to change, we can begin to take action to adjust our daily activities, our habits, when it comes to these examples that have been highlighted. And this information too can help us to mobilize as a community to ensure that legislation and certain rules are enforced to ensure that our environment are treated better. For example, there are waste collection systems, that sort waste, that recycle waste, such that these don't end up in landfills and harm our environment. Then investment in renewable energy. We use solar energy. Presently, as I'm speaking to you, there has not been electricity for a while, but we can rely on the sun to provide energy for us in batteries and use it in emergency cases like this, and even use this on a regular basis. So that reduces our dependence on the grid that may sometimes pollute the air to provide those energy. Then our water too. We want to manage water so that there is a reduction in the energy required and also the greenhouse gas required to produce them. And of course, these numbers too help us to measure ourselves. The Intergovernmental Panel on Climate Change has measurements and standards for carbon emissions. So when we're able to compute our measurements as individuals, as families, as countries, we can compare these to these standards. Mathematics enable us to do that. And those comparisons can help us to make change. So, conclusively, what have we gained from this presentation? Mathematics allows us to measure our activity and the impact they have on the environment. It helps us visualize what exactly we are doing and the negative impacts that it has on the environment. And these measurements gives us the first step to improve, to take action, to correct some of our habits that are harming the environment. And by that, we can better understand and reduce our activity, the impact of our activity on the environment. And of course, this realization should move us to take action, to make efforts to reduce, you know, all these activity, daily activities that have been mentioned or discussed, so that we can have a better and greener environment. So, as we bear the environment today in mind, let us always remember that what we can measure is what we can manage. And for us to measure, we will need mathematics to do the measurements. And thus, mathematics ensures that we have the tools to ensure a sustainable future for our various countries and the world in general. Thank you very much. Your attention is highly appreciated.
Thank you so much, sir. We really appreciate indeed what gets measured gets improved. Thank you so much. And for everyone, I just urge you to just start preparing yourself because soon we'll start taking questions. So just we can still continue sending those emojis and just appreciating because today we are celebrating World Environment Day. Let's not forget the theme. Mathematical lessons for a sustainable environment. How we're using mathematics to sustain this environment. And we've been taught different things. And I don't want to remove no subtractions, no additions. I just want to say thank you so much, sir, and God bless you. So, our third speaker, Mr. Williams, I've seen you are in the house. Please give me an emoji, Mr. Williams.
Yes.
Yes.
Okay, thank you so much, sir. So, we lost you at first, so you're our final speaker for today, and you have 25 minutes as well. So, I'll just read your profile and then you can take it over, sir.
Okay.
Okay.
Yes, thank you.
Thank you.
Thank you.
Uh,
Okay, so Mr. Williams, just a moment. Let me just read your profile and then you take it up. Mr.
okay.
Hundu Tiza Williams is a PhD candidate in geoinformatics and GIS at Host Abuja with advanced degrees in GIS, remote sensing, and geography. He has over 7 years of experience as a lecturer and researcher at Borno State University, specializing in environmental and geospatial analysis. He has led multiple based projects and currently serves as the coordinator of the Benue States chapter of the Geoinformation Society of Nigeria. So, Sir William, sir, over to you. Thank you so much. You have 25 minutes. I'll give a reminder as well,
All,
10 minutes before. Thank
all right. I am to present on a topic titled Understanding the Role of Probability in Avoiding Risk for a Sustainable Environment. Introduction. Environmental sustainability has become a crucial global priority due to escalating climate crisis, biodiversity loss, and increasing environmental degradation. The urgency to sustain natural resources and protect ecosystems is driving the alarming events such as severe floods, droughts, and, and record-breaking temperatures worldwide, which threaten both current and future generations. These environmental challenges underscore the necessity for integrating sustainability into business strategies and public policy to mitigate risk and ensure long-term ecological balance. Sustainability risk management emerges as a strategic approach that aligns economic objectives with environmental, social, and governance. It recognizes that sustainability is not merely a public relations concern, but a core element of enterprise risk management. It addresses environmental risks such as inefficient energy use, pollution, climate change impact, and resource depletion, alongside social and governance risks, thereby promoting resilient and responsible corporate practices. Central to effective sustainability risk management is the application of probability and risk assessment methodologies. Risk probability, which implies the likelihood of specific adverse events occurring, enables organizations to anticipate, evaluate, and mitigate environmental risk systematically. This probabilistic approach transforms uncertainty into actionable, insightful, guiding decision-making process to prevent or minimize environmental harm. In a critical context, probabilistic models and conditional probability sustainable principles with a rigorous risk management framework grounded in probability theory. Organizations and policymakers can better navigate the complexity of environmental challenges. This integrated approach facilitates proactive identification of risk, development of mitigation controls, and continuous monitoring, ultimately fostering a sustainable environment that balances economic growth and ecological preservation. Conceptual framework for probability and risk. In environmental context, the concept of probability, uncertainty, and risk are closely interconnected but distinct. Each plays a critical role in understanding and managing environmental hazards and impacts. Probability in the context of environment. Probability refers to quantification of the likelihood that a particular environmental event or outcome will occur. It is often used in models and assessment to estimate the chances of natural hazards, such as floods, earthquakes, etc., or pollution exposure levels. Probability provides a numerical basis for predicting how often or how likely certain environmental effect or risk might happen based on available data and statistical methods. Uncertainty in environmental context. Uncertainty arises from incomplete knowledge or inherent unpredictable unpredictability in environmental system. It is ambiguous due to the complexity of natural process and limitations in data models and expert judgment. Uncertainty can be categorized mainly as asymmetric uncertainty or variability uncertainty. Uncertainty due to lack of knowledge, which can potentially be reduced to further research or data, is referred to as asymmetric uncertainty. Variability. Inherent differences in environmental conditions or population that cannot be reduced, such as spatial, temporal, or individual variability. Uncertainty also include linguistic uncertainty, ambiguous or language and definitions, and scenario uncertainty, etc., etc. Risk in environmental context. Risk combines the probability of an event or the magnitude of its consequences in environmental assessment. Risk reflects the likelihood and severity of adverse effects on human health or ecosystem due to exposure to hazard. Risk assessment evaluates these factors to inform decision makers, often under conditions of uncertainty. When uncertainty is low or moderate, risk can be managed through monitoring and adaptive management. When uncertainty is high, additional analysis and precautionary approaches may be needed to better characterize potential risk and guide mitigation strategies. Risk management in environmental context involves balancing the probabilities of harmful events with their impact, considering uncertainties and applying policies or interventions accordingly. Probabilistic risk assessment in environmental risk assessment is a set of techniques designed to incorporate variability and uncertainty in exposure, effects, and risk estimates, providing a more realistic and transparent characteristics of environmental risk compared to traditional deterministic approach. Key probabilistic methods in probabilistic risk assessment include Monte Carlo simulation. Here, it is what Monte Carlo is one of the most widely and probabilistic methods used. It involves repeated random sampling from probabilistic distribution of input variables, such as exposure, concentration, and duration, to generate a distribution of risk outcomes rather than a single point estimate. It helps understand how variability and uncertainty affect models and sensitivity and reliability. It also used in various contexts such as human exposure to chemicals, ecological risk ranking, and toxicant effects on aquatic communities. Another method is the Bayesian networks. This is a graphical model linking causal and associated factors with response to variability using conditional probability tables. It can model complex causal and non-causal relationships and quantify the probability of outcomes based on input states. Allows reverse inference, where observed effects can inform the probability of causes. Advantages of probabilistic risk assessment. It provides distribution of risk that reflect the range and likelihood of possible outcomes rather than single observation estimates. It enhances transparency about uncertainty and variability, improving confidence in risk estimates. It reduces the likelihood of over or under risk, which is common in deterministic method that uses fixed values. Sorry. Supports better inform risk management decision by classifying the probability of adverse outcomes across different population segments or ecological receptors. Application of regulatory context. The U.S. Environmental Protection Agency support the use of PRA in various programs, including Superfund site measurement, air quality permitting, and waste disposal regulations. It also provide guidance and encourage the use of Monte Carlo method for soil contamination risk assessment, and highlights opportunities to expand probability approaches in other regulatory areas. Despite the recognition of its benefits, probability risk assessment is still underutilized in ecological and human risk assessment due to gaps
Sorry,
in.
sir. Time reminder. Just have 10 minutes from now to wind up. Thank you.
Okay. Um, okay, let me read this. Benefits of using probability in environmental risk avoidance. Using probability in environmental risk avoidance offers several significant benefits by improving how risks are characterized, communicated, and managed. Key advantages include comprehensive characterization of risk and uncertainty, improved decision-making confidence, and prioritization of research and resource allocation, enhanced communication with stakeholders, integration with other analytical tools, adaptability to complex environmental systems, support for risk reduction and avoidance strategies. Probability-based approaches to environmental risk avoidance enhances the quality, transparency, and effectiveness of risk management by rigorously addressing uncertainty and variability, improving communication, and enabling better informed and cost-effective decisions. Okay, bridging gaps between scientific probability assessment and regulatory framework. Bridging gaps between scientific probability assessment and regulatory framework involves addressing challenges in data interpretation, regulatory acceptance, communication, and implementation to ensure that probabilistic risk assessment methods effectively inform policy and standard. Key insights from recent research highlight the following. One of the challenges in bridging the gap between uh, application or the probabilistic approach and a regulatory framework in institutions. And the gaps include interpretation and acceptance of probabilistic results, one of the gaps. Lack of clear regulatory guidance is one of the gaps. Communication barriers is one of them. Resource and training constraints is one of them. There is also a strategy for bridging the gap, a suggested strategies that can be used in bridging the gap. Developing a clear guidance and standards. Then capacity building and training. Leveraging state and tribal innovations. Enhancing risk communication. Integrating science and decision-making framework. Conclusion. Probability plays a critical role in understanding and managing environmental risk by quantifying the likelihood of hazardous events and their potential impact on population and ecosystem. Unlike the deterministic approach that provides single point estimates, probabilistic method characterize the full distribution of the risk, incorporating variability, uncertainty in exposure, effects, and responses. This enables decision makers to understand how risk is distributed across potentially impacted population and ecological systems, improving transparency and confidence in risk estimates. By by estimating the probability of occurrence and magnitude of environmental hazards, such as floods, low dissolved oxygen in aquatic systems, or chemical exposed, probabilistic assessment guide more effective resource allocation, preventive measures, and community preparedness. They help identify environmental threshold and protective criteria grounded in empirical data, supporting cost-effective and scientifically robust environmental management approach. Furthermore, probabilistic approach includes Monte Carlo simulation and Bayesian network allows for modeling complex, cost-effective relationship and multiple stressors, such as climate change, providing insightful into likelihood and consequences of adverse ecological effect. This probabilistic understanding is essential for addressing mitigations strategies, informing regulatory decisions, and ultimately avoiding or minimizing environmental risk. Recommendation: to develop a clear guidance and standardized methods, enhance education and training, improve technical support and resources, foster agency commitment and strategy integration, strengthen risk communication, invest in data quality and expert judgment, expand applications and demonstrate benefits. Thank you.
Thank you so much, sir. We can just show appreciation for the presentation from Mr. Williams. Thank you very much. And I hope we have questions in the chat. From now on, we can be having questions in the chat. Just after a speech from Prof, we are going straight into questions. So we can just start brainstorming if we have any questions, or we can drop them in the chat. So right about now, we're going to have a short speech by Professor Jayola Teminope. Temitope, sorry, sir. Then it's just going to be within 10 minutes or less. I really appreciate, sir. Prof, if you can just address us within the 10 minutes. Over to you, Prof. Thank you so much.
All right, thank you so much. I want to appreciate all our speakers. I hope you can hear me, please.
Yes, sir.
Okay, please let's appreciate them once again. They've all spoken very well. The first speaker spoke on understanding the role of probability in avoiding risks for a sustainable environment. You and I know the importance of probability. It's a measure of occurrence of events here on Earth. And it helps us to prepare ahead for the future. The law of proportionality, the mathematics behind everyday environment impact. I so much enjoyed this talk. I'm going to write an email to the speaker because there are some, I need that slide. There are so many interesting things there. Proportionality, a very big question to ask is, anytime you introduce proportionality in mathematics, you talk about the constant of proportionality, which will allow us to introduce equality. And the third speaker also did justice, measurement of impact, know your footprint, measuring what matters for a greener future. The larger part of our environment is green, and we must always make it to be green. The lessons we have learned so far from mathematics for sustainable environment, mathematics plays a crucial role. You can see that it plays a crucial role in understanding and addressing environmental challenges. We can see that by applying mathematical concepts, as we have seen in various ways, we can model ecosystems, optimize resource use, and develop sustainable solutions. We've seen it in modeling population growth and biodiversity, the exponential growth and carrying capacity. There are differential equations that are involved in this. We've also seen it in the carbon footprint through algebraic calculations. We've also seen it, as our speakers are speaking to us, the renewable energy optimization, which is achievable through calculus for wind and solar efficiency, and even linear programming, how to allocate resource efficiently in energy grids. We've also seen the role of mathematics in sustainable environment in waste reduction and statistics. That is, by the time you analyze recycling rates and landfill trends using regression analysis, we saw a demonstration of this during when one of the speakers was speaking, and we saw how you apply probability models to predict plastic pollution in oceans. Another one is water resource management. And when you look at the environment, it's made up of is the union of the land, the water, that is the sea, and the air. And interestingly, just like the first person that spoke, that is the official second speaker, he took us back to the beginning. And in the book of Genesis, when God did the work of creation, we can all recall that God had to partition, when he moved the waters off the surface of the earth, he had to move waters, create the land, create the space. So you can see that God was just partitioning the whole set. And the union of the whole of that set actually gives us an environment. Water resource management, the use of fluid dynamics equation to model river flow and groundwater depletion. Game theory is also applicable for fair water distribution among communities. And another very important one is the climate change predictions, which is very important. Statistical forecast, use of time series analysis to predict temperature rise based on historical data, and also chaos theory, which studies climate sensitivity to small changes. And finally, sustainable economy and cost benefit analysis. All these, if we don't take care of the environment, is definitely going to affect our economy. Whenever there is disasters such as flooding, it can affect the economy of a nation. I mean, food items become more expensive. So the whole conclusion is mathematics provides powerful tools. We can see that from the 3 lectures we are listening to this evening. Mathematics provides powerful tools to analyze and solve sustainability challenges. So by integrating these lessons, we can see that we can develop data-driven solutions for greener future. So this is something that we should share with our students. We should make them to come to the comprehension of the fact that mathematics goes beyond theories. Mathematics is applicable to our daily living. It's important in our lives. Thank you so much for being part of this particular webinar. It has been a wonderful experience. Over to you, the moderator.
Thank you so much, sir. You've done us justice. Indeed, it has been mathematical lessons for a sustainable environment. Thank you so much, Prof. Right about now, we are going directly to Sir Joshua, who's going to take us into the questions and answer, and then he's going to give a vote of thanks. So for me, I say thank you all for joining. Right now, I hand over to Sir Joshua. Thank you, everyone, for your attention.
Well, thank you, moderator. Thank you so much. Thank you, the speaker, all the speakers that we have had this evening. I also want to thank every one of us that joined this evening to the call. It's a wonderful moment. Thank you so much for your time. Thank you so much. Thank you so much. We are trying to ensure that we all take action. Now, without wasting much of our time, please, if you have comments, contribution, or question, the floor is open to you. They'll be giving you each one at least a minute or two so that we can go back to our various activities. Yes. What's the first person? Comment, question on any of the thing. Thank you. Oh, yes. Do we have any question? Please, if you do, would like to have your question right now. Okay, while we are waiting for some of us to put up our questions, I want to say once again, um, happy World Environment Day to every one of us. And I believe that we all are looking forward to a greener world, a better world. So please, yes, I'm still waiting for comments, contribution, questions at this moment. Oh yes, while you're waiting, please, the second speaker would like to also have your presentation. That was a wonderful one. That's from Dr. Babalogbo. Yes, sir, please. Would like to also have your material. Okay, since so far so good. Yes, yes, you can go ahead, please. Yes, you can go ahead, Dr. Babalogbo, please. Okay, all right. I want to say once again a very big thank you to every one of us. My name is Joshua Ibazo. I am the convener of this very webinar. You know, it has been in my heart so that to begin to see the usefulness or the application of mathematics in every facet of our living. And just as all the speakers has mentioned, because it helps us to understand our environment better and also helps us to live better so that we can be able to create an environment that is sustainable for our living on earth. Because nature, or rather God Himself, has placed us in a very balanced environment. But our activities sometimes can create a lot of chaos and disbalance within our environment. So mathematics helps us to behave better. And that is one of the beliefs that we have based on researches that has been done, carried out from so many other persons, so that math really is transformative if we apply it to our personal living. And so on this note, I want to say once again, very big thank you. And I just want to let us know the few other events that we have for the year. As we also look up, for more um, people to come in, this is a voluntary work, and the speakers, all they have all volunteered to share with us their knowledge. This is what they pay money for. So I want to say thank you so much to all the speakers, to everyone, and to all the um, partners and everyone that have participated in ensuring that today's webinar is a success. It's really your contribution is not taken for granted. And together we are building a movement so that we can build a better world through our knowledges. And the truth is that math is applicable to every facet of our living. And this evening I was like contemplating, I think we have to do more. And I'm just looking at the aspect of empowerment and talking about financial empowerment partnership with probably a recycling company, so that we can, take much more action. And also, when we do this thing, the truth is that when we do these things, if you're a teacher here, your students, particularly if you're a math teacher, your student can really see in practical terms what we are talking about. That math is applicable, and they also have an appreciation to that. And not only that, it also impacts in their life. And we begin to have people, policymakers that, when they join the board of policymakers, they can be able to use facts, figure, to make policies that are really impactful to to our life based on what we are doing today. So based on this, our next webinar, probably intermediate, there could be one that could come in between, but for now, our webinar will be coming up by September. Yes, Mr. Nelson, yes, you raised up your hand. Do you have anything to say?
Oh yeah, I thought I had something interesting
Okay,
because
please do.
part of maybe what this good team could actually be doing for Africa is to sensitize maybe the use of mathematics in every sphere of life. One of the things I've found out in many places where mathematics is taught and expected to be used is that a graduating student, more often than not, is not aware how he is going to be useful to the economies wherever they come from. So a student can actually even leave a class of statistics, yeah, or even actuarial science, yeah, after his year of graduation, they still don't know who might use the skill, yeah, that they have acquired from school. It's one of the things that bothers me a lot because sometimes I've also sent a number of students, for example, from where we teach, to various places in industry to be able to do what we call attachment in Kenya here. One of the things I normally do is follow them and find out the kinds of things they might be doing where they have been taken for such attachment, or even for what is, well, a little more than attachment. And what I normally get is they have assigned me, now a student is reporting to me, to a task that is routine. For example, he can be a graduate of actuarial science, but who has been placed at a reception desk, which is not bad. But what I normally would ask is, how are you applying your knowledge of actuarial science acquired in class at the reception desk? Usually the answer is, I just sit and I wait for people to come and I direct them where they're supposed to be. and I'd say, oh my, your knowledge is so much wasted. Now, why? Because I know that when they are in class studying actuarial science, there are more than several things that they do, which we call core units. Among them could be, well, even things like risk theory, which then means that even at the reception, it should be very easily possible for somebody to start looking at risks that might be available or might occur at that reception, and which they could generate a model for, that kind of a thing. Then you say now, where is the lapse? Is it in the manner in which the teaching is carried out, or is it the manner in which the student received the knowledge that was imparted, or is it the culture of an African that once you have gotten this education, all you have to do is prepare and pass your examination, and then you forget, not think about how you could apply it anywhere. So I find that very brilliant minds often wasted, yeah, on account of, let me say, lack of mentoring. I think if we mentored them, then they would apply themselves a little more proactively rather than to wait to be told to do what you would call routine tasks. So if this team can aim at being a mentor to the population of students that are studying mathematics and mathematics oriented courses around the continent, we might probably be very useful before we expire. Now, that is my comment. For example, look at the definition of risk. If we were to look at risk as the expected value of loss, if we were to define it like that, then you would equip this man with that particular definition wherever they go, whether it is in a reception desk or in class or on the road, or just anywhere. Thank you, gentlemen and ladies.
Wow. 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 Thank you so much, Mr. Nelson. The part that strikes me most is the aspect of mentoring. And I think that's one of the things that we are out to. And that's why we need more partnership like yours, because so that we can transform Africa, transform our community from consumers to really, be participants in transforming our community. And mathematics just does just that. And I believe, just as you say, there are many factors. First, starting from our elementary teaching, the perception we have, and most times it carries through. And this is where we know that we have a lot of work to do. And that's why we started this awareness and this campaign. Gradually, I believe that if we take this back, it's going to do a whole lot of things within our community. Yes. Thank you so much. I don't know, Prof. I don't know if I'm correct. Please, can you help us out here?
Okay, in respect to
Yes, so Mr. Nelson's comments
yes, yes,
and
we always tell
contribution.
our teachers, as teachers, we must go beyond just teaching. We have the role of being a coach, a role of being a mentor. Is very important. We must be able to relate whatever we teach our students in the informal sciences, okay, relate them with the life sciences at least. Sciences itself is broken into so many parts. You have the physical sciences, mathematics, physics, maybe computer science. But computer science has so much grown on its own now, okay. You have the life sciences, okay, zoology, botany, and all life. So we have to understand the fact that mathematics is the queen of all sciences. It relates it links up all these other aspects of science. So as we teach mathematics in the class, as teachers, as lecturers, at all levels, college of education, tertiary institutions, even from primary school level, we must be able to relate whatever we teach the students to real life. From there, I mean, a primary school student, even a junior secondary school student, whom a teacher in mathematics has always been relating things in mathematics to with things in integrated science, who have interest in biology, in chemistry, in physics, and in engineering by the time such gets to the tertiary institution. So we need to go beyond just teaching. We have to coach and we have to mentor. Thank you so much.
Thank you so much, Prof. We have to coach and we have to mentor. Thank you so much. Thank you so much, Prof. You always make our time for this vision. And I must say thank you, Prof. Thank you so, so much. We keep doing our best and we keep creating the awareness until um, we are able to make the impact that has always been in our heart. This little drop of water really is going a long way because just as Prof has said, from my own ends, I could also include that of social science because most times I think that social area is where people relate more. Not everyone can be computer scientist or even go into pure science. But in our day to day, we socialize, we are social beings, and students want to see more of that aspect. That's why we are bringing up more of the social aspect so that we can be able to relate with it. You know, I don't know. Do you have anything to say, Dr. Joy? Okay, so that's that. Like before we call it a day, our next webinar, by the grace of God, will come up by September, and that is going to be on March for Peace on the 21st of September. We're happy to see you. But also beyond that, there are other things we'll be doing physically. By November, we'll be hopefully believing that we are going to have physically, that's going to be a physical event marked against gender-based violence. Based in whatever way you can support this vision, that will be very, very appreciated. But on this note, I want to say a very big thank you once again. Till you hear from once again. But on the group, we'll be also be dropping some excerpts from this webinar and every other thing. And I want to say thank you to um, all the partners. Thank you to everyone that has been part of this success. God bless you. Thank you, Dr. Babalobo. If I didn't pronounce it properly, please forgive me. Thank you,
You
Mr.
really
Williams. Oh, thank you. I would like to communicate with you one-on-one, please, if that will be possible. We need you in this team so that we can take this thing far. Thank you, including Mr. Williams.
Yes, thank you.
Dr. Williams, it's a pleasure
Yes,
having you. Thank you
thank you.
for sharing with us. Also, we'll be
Thank you.
discussing because this we need in our nation right now, and
Yeah.
we need to spread this gospel. Thank you so much. Thank you. And thank you. Thank you once again, Prof. Thank you, Dr. Joy. Thank you, all the listeners. Thank you, all the participants. Thank you, everyone. I want to say thank you till we meet again. Have a very wonderful night rest. If it is night, wherever you are, please take action to make sure that we have a greener world and a better life. Bye for now.
Bye. Thank you, everyone. Bye.
Oh.
Bye.